Hello, this is Jyoti Sarkar, and the aim of this experiment is to design a filter to remove baseline component below 0.4 Hz using pole zero placement method, and we will be using this to implement the algorithm on Arduino with following signals. The signals will be like PPG signal that will be sampled at 80 Hz. For three cases, that is without baseline, with baseline, and 30 Hz power line signal. So first of all, for this, since we have to remove baseline component below 0.4 Hz, we have to we have to know which filter to design. So we will be using high pass filter so that it can remove the low frequency components and it can give only high frequency components. So first of all, what we have to do is we have to design the transfer function and ultimately know the difference equation. So for the transfer equation is, we know that for high pass filter it is z into z minus 1 by z minus r. So for calculating r, we know that there are two formulas, but the condition here in this case it is specifying is fc equal to 0.4, which is less than fs by 4. So we will be using r for calculating r. We will be using 1 minus 2 pi fc by fs. So after calculating r, will be getting 0.9686 and z will be getting as 1 plus r by 2, so it will give us 0.9843. so finally our transfer equation, like difference equation, will be this equation 0.9843 into this xn. Suppose we are taking as this signal, then 0.94 minus 0.94 into x of n minus 1, then 0.9686 into y of n minus 1. So first of all, we will be uploading the signals. We will be giving the signals PPs with base, then we have given all the signals PPs without base, then PPs with power. So we are defining n equal to 100, and now we will be passing those input signals through a high pass filter. So yi equal to with base, this for with base components, and this for without base. So first of all, if we plot without base, we will be obtaining this type of waveform. You can see it is like almost similar only, because in this case there is no baseline components. So similarly, we can plot for PPs with base we have given, and this is for the with base signal, and this is for the output signal, that is after filtered signal. So if you plot it, we will get like this. So you can see that there is a small difference, like the baseline components are getting removed after passing through a high pass filter. So here you see there are spikes, like there are less number of spikes here, so we will be getting the removed, like filtered signal here. So our next case is, we will be using this signal with PPG without base, and we will be giving our own baseline component. So the baseline component we will be giving is like this bi. This will be baseline component we will be using with small magnitude 0.1, small magnitude 0.2, and another magnitude 0.15 with frequency 0.1 Hz, 0.2 Hz, and 0.3 Hz. So we will be giving our own baseline components to the signal without base, and we will be looking at the difference between them. So here we will be giving this. Then the next step we will be doing is normalizing the signal. PPG with the base signal we will be normalizing, and then we will be here x2 of I have taken, then we will PPG without base, and we are adding the baseline components. So this will be the required baseline components, and after that we will be using the same high pass filter. This is the same equation as the earlier one. This is the same equation as this. So after that, if we upload it and plot a PPC with base, this with base, and this is we are adding our own baseline component. So if we see the difference, if we plot it, we will be getting, so after uploading we will be getting something like this. So here you can see that this is the difference. This is the original signal, and we are adding our own baseline components. So this is the output. So we are getting the required, we are seeing the difference between the two signals. Now our next part will be, so in our next case in this is to use the power line signal, PPs with power line signal, and we have to remove this. So for removing this, we have to design a notch filter. So notch filter will be that we have to, first of all, for designing notch filter, we have to calculate the radius r, and we have to find the transfer function g. Then after finding those values using those conditions and formulas, then we will be getting the difference equation of notch filter as y. This equation will be getting as difference equation of notch filter. So we will be passing the PPG signal through this notch filter, then we will be removing our power line component. So after this, then we have to remove the baseline components. For removing the baseline components, this is the difference equation, this is the difference equation for notch filter. So after passing through this, we will be getting the signal with PPC signal without power line components. So our next case is to remove the baseline components. So baseline components can be removed by using the high pass filter through this equation as we have performed earlier. Now by using this, if we plot it, we'll be getting something like this. So we can see that there are less number of spikes here. So there are less number of spikes from the original signal, like the baseline components as well as the power line signal components, both are reduced. So by using notch filter and high pass filter, we have achieved our desired output. So this is the end of all the three parts. So with this, thanks.